Good morning, dear student. Myself Vikas Kumar. Today I am going to teach chemical bonding for JEE Advanced previous year questions. Special student. Now today this question is question number 1. This question is based on calculation of sigma number of sigma bond and pi bond. So according to this question, the number and type of bonds between two carbon atoms in CaC2 are. Options are given in these options. So according to this question, how many number of sigma and pi bond present in CaC2? Actually, the name of CaC2 is calcium carbide. So single bond is sigma bond, double bond is pi sigma, and triple bond is pi sigma or pi sigma. Okay. According to this concept, actual structure of CaC2 is double positive charge present at Ca and two carbon atom bonded to each other by triple covalent bond under a square bracket and two negative charge present at C2. Okay. So this is the structural representation of CaC2 or calcium carbide. Now we can easily find number of sigma and pi bond. Here pi and sigma. So one sigma bond and two pi bonds. Okay, in CaC2. So according to given option one sigma and two pi bond. So option B is correct. You can take a screenshot. Now question number 2 is based on covalent bonds. According to question number 2, the bond between two identical non-metal atoms. Identical means same type of non-metal atoms. 1 and 2 has a pair of electrons. Whenever two atoms combine together, then before bonding, both have unpaired electron. But after formation of covalent bond by equal sharing of electron between H and H atoms. So here between two same type or identical atoms. Identical means same type of non-metal. Okay. Here now here 1s1 atomic orbital of H atom. Okay, overlap with another 1s1 atomic orbital of H atom, and after SS overlap, you can sigma bond is formed. SS overlapping. So after overlapping, a single covalent bond is formed between H2. Now according to given option, unequally shared between two? No, they are equally shared. Second option, transferred fully from one atom at another? No. Third, with identical spin. Identical means with same spin? No, spin is completely different after bond formation. Equally shared between them? Yes, equally shared between them. So you can take a screenshot of this question. Now question 3 is based on ionic bond. According to this question, element X is strongly positive and element Y is strongly negative. Okay, X is strongly positive and Y is strongly negative. According to question, both are univalent. Here valency of X single plus is 1, valency of Y single minus is also 1. So both are univalent. The compound formed would be, okay. Now with the help of single cation or single anion, we can form X plus Y minus compound. Okay, X plus charge and Y minus compound. So ionic compound is formed. Okay, so according to given option A is correct. You can take a screenshot. Now question number 4 is completely based on ionic bond and covalent bond. According to question number 4, which of the following compound is covalent? These four options are given. In case of H2, in H2, single covalent bond is present. In case of calcium oxide is made up of calcium, double plus ion, oxide, double minus ion. Okay. In KCl, K single plus and Cl single minus is present. In Na2S, sodium sulfide, 2 mole of Na plus ion and 1 mole of sulfide ion is present. These B, C and D, these three compounds are comes under electrovalent or ionic compounds. But according to question, which of following compound is covalent? In case of H2, covalent bond is present. So option A is correct. You can take a screenshot now. Now question number 5 is IIT previous year question, and in this question we can calculate number of electrons in covalent bonds. According to this question, the total number of electrons that take part in forming the bond in N2. So how many electrons present in bond of N2? In case of N2, 2 nitrogen atoms bonded together. Atomic number 7, electronic configuration 1s2, 2s2 and 2p3. Valence electron is 5. Now 5 valence electron present at nitrogen. Okay. Now this structure, nitrogen equal sharing with another nitrogen, and after completion of their octet we can get, you can write lone pair here. In these representation, now total number of electrons that take part in bond forming. Okay, bond forming means in this bond 1 2 3 4 5 6 electrons present in N2 in bond. Okay, so according to given options 2 4 6 10, so 6 is correct because 1 2 3 4 5 6 electron present in bond of N2. You can take a screenshot. Now question number 6. According to question number 6, in these four options, in which compound or which molecules, in which options ionic and covalent bond both are present? One by one we can check. Initially, according to question, the compound which contains both ionic and covalent bond. Option A, in case of CH4 is completely covalent bond. In CH4, covalent bond is present. Okay. Now in case of H2, in H2 only covalent bond is present. In case of KCN, single positive charge present at potassium, and between carbon and nitrogen triple covalent bond is present. Okay, one single negative charge. So between potassium and cyanide ionic bond is present, and carbon and nitrogen covalent bond is present. So option C is correct, but we can check KCl. In case of KCl, cation of potassium bonded with anion of chloride minus, so only ionic bond is present here. So this is covalent, this is covalent, this is ionic or electrovalent, but in case of potassium cyanide, ionic with covalent compound, ionic with covalent bond both are present. So option C is correct. Now you can take a screenshot. Now question number 7 is based on Fazan rule. According to question number 7, arrange the following increasing order of their covalent character: calcium difluoride, calcium dichloride, calcium dibromide and calcium diiodide. Choose the correct answer from the option given below. According to this question, answer is arrange increasing order of covalent character in these calcium halides. First, calcium difluoride. Second, calcium dichloride, calcium dibromide, calcium diiodide. In these halides, metal calcium is common, but halide top to bottom size of halides become increases. Now from Faison rule, a small cation and large anion, whenever bonded together, then these type of compounds are show more covalent properties. Okay. Now another rule is covalent properties of anion directly proportional to size of anions. Okay. So according to this concept, you can take a screenshot. So according to this concept, size of metal is same, but size of non-metals are different. So from Faison rule, size of fluoride less than size of chloride less than size of bromide. Size of bromide is less than size of iodide. Okay. Now finally, size of fluoride is less than chloride. So size of iodide is greater than bromide. Bromide is greater than chloride. Chloride is greater than fluoride. Now these options we can set here. After that we can get calcium difluoride more covalent than calcium dichloride, calcium dibromide, calcium diiodide. Now in given options, A calcium difluoride, B calcium dichloride, C calcium difluoride, D calcium diiodide. Now we can arrange increasing order of covalent character. Okay, and according to given options, this order occurs in option number B. So option number B is correct. You can take a screenshot. Now question number 8 is based on Faison rule. According to this question, arrange the following in the decreasing order of their covalent character: lithium chloride, sodium chloride, potassium chloride, cesium chloride. Choose the most appropriate answer from the following options given below. These options are given. Now which one is correct? Now the question is decreasing order of these compound in terms of covalent character. Now compound is lithium chloride, sodium chloride, potassium chloride and cesium chloride. In these halides, metallic halides, size of anion Cl minus, so same, but size of cations are different. Now size of cation: lithium cation, sodium cation, potassium cation and cesium cation. So all are alkali metals, alkali metallic ions, top to bottom in same group. Atomic size become decrease, size of cations become decrease. So from Faison rule, size of cation inversely proportional to covalent character. Okay. Now after applying of Faison rule, here lithium cation, sodium cation, potassium cation and cesium cation, and size of cation inversely proportional to. So covalent character maximum represented by lithium cation, after that sodium, after that potassium, and after that cesium ion. Now we can apply lithium cation, sodium cation, okay, potassium cation, cesium cation. So after applying lithium chloride, more covalent, then sodium chloride, potassium chloride, cesium chloride, okay. Now lithium chloride, option A, more covalent than sodium chloride, option B, then C, then D. This is order, and this order is correct answer. So A, B, C, D. In given options, option C is correct. You can take a screenshot of this question. Now I am going to solve question number 9. According to question number 9, identify the species having 1 pi and maximum number of canonical form from the following, okay, options. Now here, according to this question, in these 4 options, in which molecule 1 pi bond and maximum number of canonical form is present? Canonical form means here maximum number of resonating structure, or what is actual meaning of canonical form? Canonical form means an imaginary structure of molecule which represent maximum properties of molecules. So this form of molecule is called canonical form of molecule. Now the answer is one by one we can check. In case of SO3, the structure of SO3 is sp2 hybridization and trigonal pair. Now pi and pi, sigma and sigma. So pi is equal to, here pi is equal to 3. And canonical form, in case of canonical form, from Lewis dot structure of SO3, we can observe this is first structure, this is second structure, and this is third structure of SO3. Now these are 3 canonical forms. So CF, canonical form of SO3 is 3. Okay. Now in this structure only 1 pi bond. So pi bond is equal to 1. Now in case of O2, we can observe in O2 pi sigma. So number of pi bond is equal to 1, and CF, canonical form, is 1. Now in case of SO3, not SO3, option is SO2. Okay. In case of SO2, the structure of SO2 is, this is the structure of SO2. Okay. Now first canonical form, and after that second canonical form is this type. Now single pi and single pi is present here. Pi is equal to 1, and canonical form CF is 2. Now the last is SO3. Last is not SO3, last is CO3 single double minus. Okay. Carbonate ion. Now the structure of carbonate is C double bond O negative, O negative. Now we can write inside the big bracket, okay, and a square bracket, big square bracket. Now this is first resonating structure. After that we can write CO3 double minus in this way, double minus, okay, and after that the last structure of COH double minus. Okay, so 3 resonating structure. So here 1 pi, 1 pi and 1 pi. So pi is 1 and canonical form CF is also 3. Now in these options, in option number 1, in this case canonical form CF, in this case also 3, CF is equal to 3 and pi is 1 and pi is equal to 1. So first case, second case, third case and case number 4. We can compare here in all cases except this case. Single pi, single pi, single pi and single pi. Okay. So 1 pi is present. But in case of maximum canonical structure, we can observe easily the value of CF is here 3, here 1, here 2 and here also 3. So which one is correct? We can compare with option A and option D. Canonical pi is single but canonical form is 3 and 3. So now we can again remember, as you know, what is actual meaning of canonical form? A form of those form of molecules which represent maximum properties of molecule by imaginary structure, which is called canonical form. So relatively, in comparison with these ABC options, in comparison with A, option D is more correct. So option D is correct. You can take a screenshot. Now question number 10 is based on Lewis acid and base concept. According to question number 10, which one of the following compound cannot act as Lewis base? Okay, so answer is Lewis acid base concept. According to Lewis acid and base concept, lone pair acceptor species is known as acid, lone pair donor species is called base. So one by one we can check. In case of NF3, single lone pair present at nitrogen. In case of PCl5, no lone pair at central atom. In case of ClF3, two lone pair present at central atom. Now in case of SF4, single lone pair present at central atom. So in these 4 options, only in case of PCl5, no any lone pair present at central atom. Okay, so this molecule cannot act as an acid or base. So option B is PCl5. B is correct.